Last time we had started operations on functions, and in particular we started by looking at the four basic operations: addition, subtraction, multiplication, and division. And I think I said something like everything that you would expect to be true simply is true for those four operations. And I defined them exactly like we would expect them to be defined, and I believe we did these three examples. Okay? So I have a few more with these particular functions, f of x equals 2x and g of x equals 3x squared. And we're going to find a couple more. So we're going to find f times g of x, and then f divided by g of of 4, and then look at some domain issues. So let's take a look at the first one, f times g of x. So if we're looking at f times g of x, it should be f of x times g of x, which are exactly the functions we're given, 2x times 3x squared. And what do I get if I multiply 2x times 3x squared? Six what? 6x cubed, right? Powers of x, or exponents, powers get added together when their bases are identical and they're being multiplied. That's it. There's nothing else to do. It's 6x cubed. This one actually has two components. One component is the fact that there's division. The other component is the fact that there is evaluation at x equal 4. Does everybody see that? There's two different things to do. So one issue is that I'm supposed to write f over g, but it's not really f of x. It's really f of 4 over g of 4 that I'm trying to find. So in my f of x function, that's this one, I have 2 times x, which is 4. And in my g of x function, I have 3 times x, which is 4 squared. Then we need to do some multiplication and potentially reducing or division going on. So what's on top? 8. On bottom, I start with the squaring, so what's 4 squared? 16, and then 16 times 3 is, it's 48, that's right. 8 and 48 are definitely divisible by something, by 8 in fact, and it is 1 over 6, that's right. Okay, now on f, it references f over g, but I didn't ever actually find f over g. I evaluated it very specifically at 4. So in order to do this, I first need to find f of x over g of x and see what happens. So f of x was 2x, g of x was 3x squared, and we've done this. We've reduced functions just like this before. What will reduce? The x with one of the x's on bottom. So what will that leave me with? 2 over 3x. Now when it talks about values not in the domain, there's two different functions that tend to kind of crop up when it starts asking those questions. Denominators, rational functions with denominators, and square roots. And this one is the rational one with the denominator. So we want to ask ourselves, are there any values x cannot be for this function? And there is. What value can x not be? Yeah, x can't be 0 because then I'd get a 0 in the denominator. Okay. Any questions on that one? Now, these functions were very friendly, right? One was a line, it's linear. The other one was a quadratic, it's got x squared in it. So we're going to change things up and make the functions not so friendly. F of x is going to be x over x minus 5, and g of x is going to be x plus 4 over x minus 5. They have the same denominator, so that's kind of friendly. It could be worse, I guess, is my point. On part A, it asks me to find f over g, right? Division. So I can write that as x over x minus 5 over x plus 4 over x minus 5. we've seen this kind of function before. Do you remember what we called it? Called a complex equation or complex function. Fractions within fractions. So how are we going to change this so I don't have a fraction within a fraction? Do you remember? Yeah, it can multiply by the reciprocal. So this can be rewritten as x over x minus 5 times x minus 5 over x plus 4. And that's actually a little bit friendly because what happens along one diagonal? Yeah, the x minus 5s cancel out, right? And so I'm left with x over x plus 4. Way friendlier than what I started with. Still a fraction, but a much nicer looking one. Now part B asks for the domain. So I'd like for you to start by looking at the end of this, the final answer. Looking at the final answer, what value can x not be? What was it, Keely? Negative 4. If I let x equal negative 4, I get a 0 in the denominator. That's no good. So x cannot equal negative 4. However, I did some work along the way where I eliminated something. I eliminated a denominator. Well, x can't be 0, or not x, but the denominator can't be 0 there either. Even though it gets eliminated, it still can't be 0, right? So there is another value I cannot have. And what happened when I eliminated this denominator? What value would make that denominator 0? It would be 5. So I also have the fact that x cannot be 5. It's easy to overlook that one and forget it because, I mean, we canceled it out. You can't cancel out zeros with multiplication. It doesn't work. You still end up with undefined values. What you actually end up with, in case you remember doing this, we haven't talked about this, but you end up with holes in graphs. That's what happens when you cancel things out. There's a hole in the graph. All right, so this is the domain of f of x. I'd like to show you again how we write that in interval notation if you're asked for interval notation for this one, which you could be on some of your problems. So in an interval notation, if you think about the number line, we have a negative 4 here and we have a 5 here, and I'm supposed to be able to have all the values except those. So I have all of this, and all of this, right? And the way that I mark that I cannot have those values is I use parentheses to separate them off. So this actually would be negative infinity to negative 4, negative 4 to 5, and then 5 to infinity, like that. So if it's not asked for interval notation, then you don't have to. But if you are asked for interval notation, that's what it would look like. Okay? Any questions on that one? All right, let's shift gears and try a different type of function. One with a radical, square root. So part A is asking the same question that the last part A asked, but I end up with a denominator that has what in it? Yeah, square root. So not only can the denominator not be 0, but it's also true that what's underneath the square root cannot be what? Negative, because we're working in the real number system. So I need to know, for part B, what the domain is. In particular, I need the denominator, what's underneath the radical, to be strictly greater than 0. Normally greater than or equal to is just fine, but if it were equal to 0, I'd get a 0 in the denominator. So since the radical's in the denominator, it ends up being just greater than 0. And what would x then be greater than in that case? Negative 2. And again, if you were asked to put this in an interval notation, not that you necessarily have to draw a graph, but greater than negative 2 would be this side, and again, not equal to, so it would actually look like negative 2 to infinity if you needed an interval. Now I'd like to stick with the same equations for f and g, but we're going to do something else with them next. Instead of finding the division, right, f divided by g, we're going to find the summation. So, summation means I do what? What's it asking me to do on this? Just add them together, right? So I have 3x plus 1 plus square root of x plus 2. That's the function. But on part B, or part D actually, I'm asked to find the domain. So how do I find the domain of that function? What are some pieces of information that are valuable? Okay, it all hinges on the radical, right? The other part can have any x value you want, but the part that's in the radical can't. What is the radical telling you has to happen? Okay, well, we're not squaring anything. I'm really not solving, I'm just finding domain. What do you know about radicals, though? What kind of values can you have or not have underneath radicals? Yeah, positive or 0, right? Yeah, so I need the values that are underneath the radical, which in this case is x plus 2, to be greater than or equal to 0. Why do I get to equal 0 here, but on part AB I did not get to equal 0? Yeah, this radical is not in the denominator. So it's perfectly fine for this radical to equal 0. It just couldn't on the previous part because it was in the denominator, and that caused an additional problem. So if I were to solve this one, I have x is greater than or equal to negative 2 now. And if I were doing that here, how will that be different when I record it in interval notation? Yeah, I use a bracket. So this would be negative 2 to infinity. Okay, everybody good with addition, subtraction, multiplication, division? Okay, everything occurs like you would expect. There's one other type of combination, and it's a little messier, and it's a little harder to think about the domain for it, okay? The other operation that we're going to do is called composition of functions. And it looks a little bit like it's a tiny little O between the functions. This word does not say fog, by the way. That is not what this says. It looks kind of like it, but that's not what it says. And what it is actually saying is f is composed with g. So what does that mean? Well, it means that I take the function g of x and I put it inside of the function f of x. So I'm sort of embedding one piece inside of something else. So we often see parentheses used when we're looking at these sort of embedded functions like this, these compositions. So we're going to do some examples. Q of x is negative x minus 3, and r of x is x minus 2. And this says Q of r of 2. So what it really means is Q parenthesis r parenthesis 2. That's what you're doing. Q of r of 2. And just like any other time when you have parentheses, you start on the inside and you work your way out, right? Order of operations. So we're going to start on the inside. Our inside is r of 2. So over here, I'm going to find r of 2. What does it mean? What am I doing with the equation r if I'm looking for r of 2? Yeah, I'm plugging 2 in for x. So in that equation, it would be 2 minus 2, which is what? 0. So So I can go back to where I was working originally here, and I can replace this value with 0. Because r of 2 is 0. What am I going to do to find q then of 0? Yeah, I'm going to go into the other equation now. I'm going to plug in 0. So that would give me 0 minus 3, which is negative 3. Now, a lot of operations we can do them in, well, 2 operations, we can do them in any order. So like addition, right? 5 plus 2 is 2 plus 5. Multiplication, 5 times 2 is 2 times 5. So that's called the commutative property when we can change the order of things. So we're going to change the order on part B and see whether or not that actually matters for composition, okay? And then we'll be able to make the claim at the bottom where it says note, and we'll either be able to say that they're equal or that they're not equal. So we're going to try it again. This is now r of q of 2. And I start on the inside, which is q of 2. Okay, so q of 2 means I go to which equation? The first one, the q equation. And what do I do with the 2? I plug it in for x. So there's already a negative here. I plug the 2 in for x, and then I have minus 3. What is q of 2? Negative 5 is right. And then I go back over to what I'm actually looking for, and I replace q of 2 with its equivalent version, which is negative 5. Now it says I'm going to find r of negative 5. So let's go to the r equation. And I'm going to replace the x with negative 5. So I have negative 5 minus 2, which would give me what? Yeah, negative 7, which is correct. So, does the order matter? Yeah, I get different answers if I do q first or if I do r first, right? If q's on the outside or the inside, it makes a difference. So it's actually not a commutative property. I can't just do it in whatever order I like. The order makes a difference. Okay, so this one was a very specific value where I was plugging numbers in, 2s and 3s and stuff, right? I was putting numbers in for things. But sometimes there aren't numbers to plug in. We're supposed to be finding things in general. So if I'm finding things in general, what I see different is I don't see a number right here. Do you see that? It's just not present. So we're going to do this now without a number to plug in and see how that looks. So again, I'm going to write out h of g of x, just like I did in the last problems. I replace the inside with function g of x, because it's second, right? It's the one that's closest to the x already. Now, what is g of x? Seven over x, right? So I'm going to replace g of x with 7 over x. That's what it is. It's 7 over x. Now, you've seen this before. You've seen functions that say f of stuff, and it's not a number. It's got other stuff in it, variables and so forth. What do we do in order to work with this problem? What will happen with my 7 over x? Okay, what if it just said 7? If this said h of 7, what would you do? Okay, you'd replace the x in which equation, Megan? Okay, so you'd come up here to the h of x equation, and you'd replace the x with 7. So we do the same thing. It doesn't matter that it's not just a number. We still go back to the same equation, and we replace the x with 7 over x. So where I previously had an x, I now have 7 over x. That value is squared, and then minus 1. I'm still just doing replacements. We can clean this up a little bit. What will this look like if I clean it up? I feel like you guys need to stand up and do jumping jacks. I'm squaring, right? What's the numerator become? 49. And the denominator? Yeah, x squared. And then minus 1. That's it for that one. Like, it stops there. If you were asked to find domain, you would know that x cannot equal what? 0. Okay, we're going to do it in the other order. This one says g of h of x. What is h of x? Yeah, it's x squared minus 1. So what am I going to do now with x squared minus 1? Now we're going to substitute it in the x in the g of x equation. So here's my g of x equation right here. And I'm going to replace the x, which is in the denominator, with it. So that's 7 over x squared minus 1. If you were to do the domain, what can x not equal there? Yeah, positive 1 and negative 1. Actually, neither one would work. Yeah. And, oh, that's a different one. Okay. Any questions on that one? Okay, order matters. It does matter which one they list first. C and D are different. So C and D say the same value twice. Like, it says G compose G. It says H compose H. And that's totally fine. We'll rewrite what that means. It means G of X. And you know what G of X is. It's 7 over X, right? So what would I do with 7 over X if it's asking me to do G of 7 over X? I'm going to substitute it into the x in the g of x equation. So I'm still going to have the 7 that's on the top of g of x, and then on bottom where I had x, I now have another 7 over x. And that's complex fraction. Fractions inside of fractions. So what do I do to change my complex fraction to be not complex? Yeah, we're going to multiply by the reciprocal of the denominator. And what's the denominator's reciprocal? X over 7. And lovely things happen. What happens? Yeah, the 7's cancel. So this just leaves me with x. Okay, let's do the same thing for h. Please always start by rewriting h of x. And it tells me that h of x, the part that's inside, is x squared minus 1. Now what am I going to do? In which equation, Karen? Yeah. I'm going to go back to the h equation. And I'm going to plug into it x squared minus 1 for x. So I have x squared minus 1 squared, and then minus another 1. So I am embedding a function inside of another function. That's what I'm doing every single time. The order and where it goes change because the x changes its location. For this, we'll simplify out. This would be x squared minus 1 times x squared minus 1. What is x squared minus 1? Times x squared minus 1. Sorry, stop talking. I'll start you out. X to the 4th. That's x squared times x squared. What's next? Yep, the inside and the outside terms are both minus x squared, so there's minus 2x squared. And then what's on the end? Plus 1, and then I have my minus 1 from the outside, right? So the plus 1s and the minus 1s add to 0, and I have x to the 4th minus 2x squared. Okay, is that all right? Awesome. We're going to try one more, and then we're going to shift gears for the last time in this section. F of x, oh, there's a typo. Do I have a typo here? Yeah, this should say 11 over 2. It shouldn't say 11 over 2. It should say 11 over x. There we go. All right, so f of x is 1 over x minus 4, and g of x is 11 over x. And we're supposed to find f of g of x. Like this. And g of x is 11 over x. Now what? Plug it into the x in which equation? The f equation. So this would be 1 over 11 over x. And then minus 4. Is that okay? Complex fraction, but it's not a fraction over a fraction. So I can't just multiply by the reciprocal because I don't just have a single fraction in the denominator, right? So what did we do to try to get rid of these double fractions when we had a situation like this? Do y'all remember? Nobody remembers? We multiplied the whole thing by something. Do you remember what we multiplied it by? Which denominator, Devin? Like, I thought it was Devin. Oh, it was Keely. I'm sorry. It was in that same area. I'm sorry. Keely, which denominator are you referring to? Yeah, the x, like the little denominator, right? Yeah. So we can actually multiply, like Jonah said, every piece of this by the same quantity, and it's the little denominator that's causing the problems. It's what's causing the fraction inside of the fraction. So I can multiply each of these pieces by x. So I have x on top, and then I have 11 on bottom, and then minus 4x. Is that okay? All right, so that's the answer for part A. Part B starts talking about domain. And there are two domain issues here. One of them is the end result. We always look at the end and say, what can x not equal? So if I were to look at this denominator, what value can x not equal, or how could I find it? How could I find the value I'm looking for? Something to do with the denominator. Yeah, I set my denominator, which is 11 minus 4x, equal to 0, or you could even say not equal to 0, actually, because we're looking for what it does not equal, right? And we can solve from there. So negative 11, so if negative 4x does not equal negative 11, and then if I divide by negative 4, then x does not equal, and it would be 11 over 4. Almost 3, right? Almost the number 3. But there's one other location where I had a denominator that sort of disappeared in the mix of things. What denominator disappeared? The x. So if I disappear a denominator, just like I did over here, when I disappeared the denominator, was it this one? Yeah. I still have to consider that that can't happen. That value still can't be a 0 that I, may go away. So another possibility, of course, from right here, really, is that x cannot be 0. So there are two values x can't be. And if I were doing them on a number line, 0 comes before 11 over 4. And then I have all the pieces in between and around. So I'd have negative infinity to 0, 0 to 11 fourths, and then 11 over 4 to infinity. If you want to change 11 over 4 to a decimal, you could. It's 2.75. If you really wanted to do it as a mixed number, you could. It's 2 3/4. Any of those would be okay. Okay, so I don't remember how long ago it was now, but a few class periods ago, there were 3 problems at the end of your assignment that I told you to mark out. Do you guys remember that? Yeah? Do you remember what they were called? They had the word quotient in them, you're right. Anybody else? Okay, that's all right. They were called difference quotients. And I want to talk to you about what a difference quotient is, because this is really where it fits. Difference quotient is used further along in math. Specifically, it comes back again in calculus. And I know some of you are headed that way if you stick with science as your major, because many of the science majors require calculus. Not all, but many do. If you're nursing, they don't require you to do calculus. You do some other stuff, but the traditional science majors, many of them require calculus. What the difference quotient does is it calculates how something changes. And we calculate change all the time. Sometimes you call it slope, right? How something changes. Whenever you're driving in your car and you're speeding up and you're slowing down, that's how something's changing. When you look at what you sort of expect your salary to be a year from now, you're looking at how something's changing. So we look at how things change all the time, and a difference quotient just calculates change. What I'd like for you to see is that there's kind of 3 parts to this difference quotient. Yeah, I thought I was going to do here. The first part is this piece. So the first step in finding the difference quotient is to find f of x plus h. Okay? And if you're thinking about moving through this expression, the next piece would be continuing the numerator, right? So the next piece would be subtracting the f of x. And if I've done step 1 and step 2, I've done the whole numerator. So what is the last thing that I haven't done then? Yeah, step 3 is to divide by h. So sometimes this is taught in such a way that you just do it all in one fell swoop, and you can do that. If you've seen this before, you feel comfortable with that, you can. To me, I think it looks a little bit overwhelming when you put it all together from the beginning. And so I like to break it down into pieces. Okay? So let me show you how this works. You ready? Don't get too excited. Okay, here's our function. F of x equals 4x squared minus x plus 9. And we're asked to find the difference quotient. If you want to break it down into steps like I'm going to show you, please at least number your steps. Okay, you don't necessarily have to write out my labels. Like you don't have to write down f of x plus h equals. You don't have to write down the words subtract f of x and so forth. But at least number that your steps are different. Because at some point in here, we're going to go from step 1 to step 2, and they're not going to be equal values, right? I'm doing something else that I wasn't doing before. Whereas a lot of time we just keep working our way down the page and each step is equal to the one before. That's not what's happening. So you need to label the values or the parts that you're doing so at the very least it's indicating that there's something different going on in the next step. So I will label mine as well because it helps me to keep track of where I am. The first thing I'm supposed to do is to find f of x plus h. What does that mean that I do? Put the x, what was that? Okay, so we're going to put the x plus h in for the x's. Okay, so if I had like we had a minute ago, some problems that said something like f of 2. It would mean replace the x's with 2, right? Okay, that's what that notation would mean. So our notation means replace the x's with x plus h. So I'm going to have 4 times x plus h squared minus x plus h, and then plus 9. I replace the x's with x plus h. All right. So x plus h squared means I have x plus h times x plus h. I can distribute the negative through this. This is negative x minus h plus 9. And I'm going to multiply by my 4 last. I think that actually makes it easier to work with myself. If you don't want to do it that way, that's fine. But if I multiply x plus h times x plus h, I'm going to get x squared. And then what? What do I get on the outside part? Yeah, I get xh on the first part on the outside. I also get an xh on the inside. So there's 2 of them total. So I have 2xh. And then what about the last piece? Yeah, h squared, right? What's the last thing I need to do? Distribute the 4, yeah. So I have 4x squared plus 8xh plus 4h squared minus x minus h plus 9. That's it for step 1. It's the hardest step. This other steps actually take the mess that's there and they reduce it and simplify it, okay? So everything's going to get cleaner after that point. What was step 2? Yeah, it was to subtract f of x. So everything I already had, if you want, you can rewrite it. I will do that. Okay, and then I need to subtract off f of x. So what is f of x? Well, it was given to me. It was 4x squared minus x and plus 9. Okay, you might notice I put it in parentheses. I need to because there's a minus. I need to subtract everything, right? So that's why I put it in parentheses. But it's actually really nice as well because if you take a look at what's going on, what is going to happen, everything that's in that set of parentheses is going to cancel out. That is, it's going to add to 0 with something from before. Let me take an example for you. 4x squared here and 4x squared here add to 0 because there's a negative here making that a negative 4x squared. Okay? So I can cancel these out. And then do you see the negative x's? There's a negative x here and a negative x here. So those can cancel out. And then I see a plus 9 here and a plus 9 here, and those can cancel out. So I just made my problem have quite a bit fewer pieces. I have an 8xh, I have a 4h squared, and I have minus h. If you did it right, every term has an h in it when you're done. If you see that you don't have an h in one of your terms, there's an error somewhere because they have to all have h in them. Because what's step 3 going to be? It divides by h. And when I divide by h, it will cancel out the h I'm dividing by as well. That will always happen. So I have 8xh plus 4h squared minus h over h. And it will reduce with each of the h's in each of the pieces in the numerator. So that h in this one one of these, not both of them, but one of them reduces. And then what happens at the end here when I cancel this h out? I'm left with a 1. Don't disappear it and become a 0. That's not true. H divided by h is 1. And so this one would be minus h, so it's negative 1. And when I compare all the pieces of what I've left, I have 8x plus 4h minus 1. That's the difference quotient.
Can you explain the minus 1 again, please?
Yeah, this is division. If it helps you to think about it, you could divide it piece by piece. I had a different marker going. Like that. So these h's cancel. One of these pairs cancel. And when I take h divided by h, I get 1. Yeah, it's a little easier to see written that way, so if that helps, do it that way. Any other questions? Okay, so you're going to see difference quotient on the bottom of your paper when I give that one out to you.